Bismillahirrahmanirrahim. Hi, I am Dr. Abdul Adamu from Data Analytica. This video is on MSquare Alpha. It is a continuation of video on portfolio performance. If you have not watched our video on trainer ratio, you can click up here to watch that video. And if you have not watched that of sharp ratio, you can check our YouTube channel to watch the video on sharp ratio. Now, MSquare Alpha is also known as risk-adjusted performance. It was developed by Franco Modigliani and his granddaughter Leah Modigliani in 1997. That is why it is called MSquare. Modigliani and Modigliani in 1997. They call it risk-adjusted performance measure or RAP. While MSquare Alpha, which we'll see later how it will be calculated, compares portfolio return that is adjusted for the total risk with the benchmark market index. It shows the extent of whether the portfolio have overperformed or underperformed. And it is related to the Sharpe ratio and also ranks portfolio identically. We are going to see later that the formula for MSquare is an extension of the Sharpe ratio. It is denominated in percentage return by assuming the same level of total risk as the market. MSquare also assumes a portfolio is leveraged or deleveraged until its volatility, that is the standard deviation, matches that of the market. Is the portfolio excess return times the leverage ratio plus the risk-free rate. So if you look at the formula for MSquare, you can see it is excess return, that is the return of the portfolio less the risk-free rate, multiplied by the ratio of the market standard deviation all over the portfolio standard deviation. So if you compare this with the formula for our Sharpe ratio is this divided by the standard deviation of the portfolio. So, and you now add the risk-free rate return again. So that is why we said this part of the formula, this and this, is the Sharpe ratio multiplied by the standard deviation of the market plus the risk-free rate. So the MSquare ratio is compared, once this is computed, we normally compare it with the actual market return. So if we compare it with the actual market return, we'll be able to determine whether the portfolio has outperformed or underperformed the market on a risk-adjusted basis. So MSquare Alpha, which we are going to get after getting the MSquare Alpha now is the difference between this value of the MSquare with less the return of the market, with less the return of the market. So that is the MSquare we calculated minus the return of the market. So let's take example and compute our MSquare Alpha. So if we take our example from the question we adapted from the CFA Level 1 program curriculum of 2020, and we take it, let's see, this is the table showing the average return, the standard deviation of various portfolio and their beta. So we want to calculate the MSquare Alpha. Now to calculate the MSquare Alpha, these are our formula for calculation of MSquare and the MSquare Alpha. So the rates for the portfolio, for X we have 10%, we less the risk-free rate, which is 3%. Then we divide it by the portfolio standard deviation, which is 20%. That is this factor here. We now multiply it by the standard deviation of the market. So the standard deviation of the market is 19. That is what we have here, plus risk-free rate which is 3%. So if we evaluate this, we are going to get 9.65%. So if we have 9.65%, if we remove the return of the market, the return of the market is 9%. So this minus 9% will give us the MSquare alpha. So the MSquare alpha is positive, which means this portfolio has outperformed the market by 0.65 percentage point. So for Y, we key in our inputs, this minus this, divide by this, plus the 19%, which is the standard deviation of the market, plus our risk-free rate, we have 18.2%. So if we subtract our market return, then our MSquare alpha is going to be 9.2%, which also shows that Y has outperformed the market. Also for Z, if we key in our factor and we substitute, we have 9.84%. If we subtract the 9% of the market, we get our MSquare alpha, which is 0.84%. It also shows that it outperformed the market by 0.84%. So for that of the market, the value is 9%. So this is going to, the MSquare alpha is the same as that of the market, since we are subtracting it from the market return. So we can see that all the portfolio outperformed the market, but the one that has the higher, if you are ranking it, the one with the highest MSquare alpha is portfolio Y, with MSquare alpha of 9.2%, followed by portfolio MSquare alpha of 9.2%, followed by portfolio Y X portfolio Z 0.84%, then portfolio X. So in that order, that is how we are going to rank them. Y has the highest, followed by Z, then followed by X and N. So this is how we do the computation. If we go to our Excel, we can do this computation easily in our Excel. So in our Excel, if we go, our MSquare will be, we have this part, this is equals to bracket open R is this minus the risk-free rate, which is this. We are going to lock it with F4, close. We multiply it by bracket open the standard deviation of the market. The standard deviation of the market is this. We are going to lock it because it's common with all. F4 divide by the standard deviation of the portfolio. We are not going to lock it. We leave it like that. Plus the risk-free rate. The risk-free rate is 3%. We also lock it. We enter. That is the value. We just copy it down. So those are the value that we got earlier. So the MSquare alpha, this will be equals to MSquare minus the return of the market, which is 9%. We are going to lock it since we are copying it down. Enter. We have 0.65%. We copy it down. So those are our value, the value that we got earlier. So this brings us to the end of how we can compute MSquare alpha. And if you enjoyed the video, consider subscribing at Data Analytica and hit the notification bell so that when we drop any video, you get it. So if you have not watched that on Sharpe ratio and trainer ratio, you can check them out on our YouTube channel. Thank you for listening.